What's going on, guys? It's the Unhinged Engineer here. And I know we've all heard the horror stories about computer science in 2025. Whether it's oversaturation and super competitive jobs and putting out like thousands of applications without hearing anything back, or the literal threat of AI just taking all the jobs away straight up. There's been lots of buzz around whether or not computer science is a viable degree to get. And I think a lot of people err on the side of no. And to be honest with you, I'm kind of inclined to agree with them. And if not totally agree that CS is a bad degree, I at least think that there's some hesitation that should be taken in terms of whether or not this is what we study. And there's some fallacies, like faulty reasoning that people use that leads them to think, oh, CS is a great option for me, when a lot of the time it's really not, right? And this is coming as somebody who studied aerospace engineering, worked as an aerospace engineer, then started doing software engineering and AI/ML, and is now currently getting a degree in computer science, believe it or not, a master's degree. And so all of this is to say, I've seen the gamut of how computer science interacts with the rest of the engineering world as a degree and as a field. And I want to talk about why you shouldn't study it and what you should do instead. So if you're new to the channel, welcome. I'm the Unhinged Engineer. I make professional development content for young engineering or other STEM types of professionals like myself. And if that's something you're interested in, then this is a channel for you. And let's get right into why I think most people's perception of CS is faulty, right? I think at its core, there's this assumption that if you like coding, okay, so I like coding, I should study computer science. That's the general line of thinking. Oh, I'm in high school, or maybe I took my first coding class in like freshman year of college. I like this is pretty good. I should study computer science. That's the logical progression that leads a lot of people to do this. And I honestly don't think it's the right approach, right? Here's what I think you should do instead. I think if you like coding and you see the horror show that's going on, right? So this entire video is predicated on the idea that maybe you're a little wary of this degree to begin with. Like, you're interested, you like computers and you like coding, but you're looking at the shit show that's going on, you don't know if you want to get into all that. That's what this video is premised on. If you're in this position, I would advise you do this. Study traditional engineering, and learn to code while you do it. This is my very dramatic, radical, crazy hot take. That was sarcasm. It's not that hot take, right? When I say traditional engineering here, I'm referring to mechanical or electrical or chemical, civil, aerospace, biomedical, whatever else. Pick some kind of engineering that's not computer science, and then just learn to code while you're doing it. Some of that will be self-paced, self-study on your own. Other parts of it will be baked into the degree itself, and that's part of what I want to talk about today, right? So study traditional engineering, and then learn to code while you do it. And for the record, I am obviously biased because this is what I did, and this has led me well so far, right? And I think there's a few reasons why. Right? I have some notes here. Couple things. Number one, we have to talk about the tech industry, okay? I think when people think CS, so there's a through line, right? Coding to CS, and then from CS they think bang, right? Bang, tech companies, Facebook, Amazon, Apple, what's the new way they say it? Manga, right? Whatever. Like these kinds of companies, big tech companies, and if not one of these, some kind of startup, like your second cousin is making a website, where they sell gophers on the internet in an auction, right? Like weird startups, tech companies, jobs abroad, unpaid internships. Like this industry, I'm going to be honest, like I am a much bigger fan of traditional engineering industries like, mechanical engineering or civil engineering, defense companies, right? Petroleum companies, like oil companies, medical, pharmaceutical stuff, like these, HVAC, electrical, DSP, these kinds of things, right? These old school engineering companies aren't being plagued by the instability and the hyper competitiveness and the influx of AI agents, right? All these things that like you're gonna have to deal with if you're trying to get a job at OpenAI. Okay, like this industry, I think the tech industry is great, pays super well if you can get in. There's definitely benefits to the tech industry. I'm not saying it's a bad place to work, but I'm just saying a lot of these problems around AI and competitiveness are really about FANG or tech, I should say. And CS kind of biases you towards tech. So by studying things like I mentioned earlier, you're biased away from the tech industry. And I think overall, that will serve you well in the long run, right? Just based on how that's going. My second point here is about the fact that you're going to learn how to code anyway, right? So engineering will require coding, okay? Even weird classes that have nothing to do with it, like thermodynamics or heat transfer, aerodynamics, strength of material stuff. Like you're still going to be writing code to simulate or model the things you're learning in class, right? So you're going to write code in stuff like MATLAB or Python, stuff like that. You're going to be writing this code anyway, and so everyone's going to learn how to code as they go through, at least to some degree. Now, if you love coding, if you like coding, and you're doing this, you're going to go above and beyond. You're going to jump at opportunities that have a lot of coding. Like hopefully you join clubs and you gravitate towards that kind of coding-oriented work, even if it's not the computer science and I want to work at Amazon club. Maybe it's the Formula SAE club that's building like F1 cars, student teams, or eco car, or design, build, fly for aerospace or stuff like that. You're going to join these clubs. You're going to gravitate towards the kind of coding work that those fields require, and you're going to learn to code. Okay, it's going to happen. Right? And that leads me to my third point of differentiation. Okay? In my opinion, it's not enough to be the best. It's also not enough to be just unique. If you're crappy in your own way, nobody really cares. You really have to be both. You have to be awesome at what you do and in a way that is different from anybody else. That's how you really stand out, right? And so if you're just studying CS, it's the expectation that you learn how to code, which is, I think, a bad expectation, but we'll get to that in the next section, right? It's the expectation that you learn how to code. So however good you are at coding isn't really a differentiator. But now let's say you go to a defense company and you study mechanical engineering, right? And during your mechanical engineering degree, you learned about heat transfer, instructional mechanics, and dynamics, and control systems, and all these different things. And you like coding, you're a rock star, you've learned these different languages. Maybe you've gone out and learned other languages like C++ or whatever. Like that, now it's a differentiator, right? So it's something that stands out, and it's more likely to help you, be that X factor that gets you the job. And by the way, take it from me as somebody who's working in AI, even if you go work in tech eventually, if you go against the advice from earlier and you work at a FANG company, that, like, having studied a different kind of engineering is still going to be a differentiator, right? So let's say you go to work at NVIDIA and they're doing their fancy, robotics, AI stuff, and you study mechanical engineering. So you know about mechanisms and controls and all the other stuff, mechatronics, right? You've built little robots in school and whatnot. Again, it's a differentiator, even in the tech industry, right? So all this to say, it's about differentiation. If you study CS, coding or any coding products you've done or being good at coding or whatever else is not a differentiator. It doesn't stand out. You might be great at it, you might be the best at it, but it doesn't stand out. If you do other stuff, then it's going to be a differentiator, which is really great. And then lastly here, I'll write it up here because I'm running out of room. 4, CS doesn't teach coding. Now, I know this sounds dumb, right? But I am getting a computer science degree right now. I have learned 90% of my actual skills of being a software engineer and writing good deployable code, right, from my job. I have not learned it from coding in computer science, right? Despite it obviously being the type of engineering major that requires the most coding, right? I understand that. I'm aware. Believe me, with all the homework I have, I'm aware. What it teaches you is math and algorithms and conceptual frameworks relevant to how computers work, right? It's computer science, not coding boot camp. Two different things, right? So if you want to learn those things, then by all means, go study computer science, right? Which is what I'm doing right now for my master's degree. Just don't do it first, right? Learn to code first. Learn to code, get really good at it, start making money doing it, and then if you really want to learn that stuff I just referred to, then go back and study it. Or if you're still in college, take electives later, computer science electives, whatever, right? The point I'm trying to get at here is computer science is about computers, right? And if you want to work on computers, that's great. I would recommend studying computer science in that way. But this, it still like ties back to the fact that I think this logic of I like to code, therefore I should study computer science, and therefore I should go work at Apple, whatever. Like, is leading people to starve when there's lots of food in other places that they could be eating, right? So yeah, I mean, for me, I studied aerospace engineering. I gravitated towards guidance, navigation, and controls. I did a couple different internships and whatnot in that field. And then I got a job doing software engineering for AI, computer vision, because it's kind of related to certain robotic systems, right? While I was working that job, I realized, oh man, there's lots of algorithms and operating system internals and different things, like how virtualized memory works, like these computer things I don't know because I didn't study that. I studied aerospace engineering. I'm going to study CS now, and it served me really well because I have that foundation in actually being a good programmer, right? Like first, and then I do think like computer science doesn't directly teach that. By the way, if I ask any of my friends, my friends I know who are the best coders, right, they will tell you that themselves. They learned coding on their own. Computer science helped them do leak code, right? It's very different. So yeah, this is my hot take. Not really that hot of a take, right? And I really do think, like, let's say for argument's sake, you really want to code, and you're scared that if I study, mechanical or electrical or whatever else, I'm not going to get to code, right? People don't realize just how ubiquitous coding has become, right? So if you're a mechanical engineer, there's simulations. Whoops, can't write. There's simulations. There's finite element analysis. There's control systems. There's mechatronics. Let's say you study electrical. Electrical is probably, I've never studied electrical, so I'm not going to speak for it specifically, but I would imagine electrical is really the best one if you're like a diehard here, right? There's computer architecture. You will learn that in electrical engineering. There's like logic gates and FPGAs you're going to learn about, right? FPGAs are absolutely huge. Also a pain in the ass program, but that's a different video. All this to say, like, coding is here to stay. It's not going anywhere. It will be okay. This is not like in 1980 where 5 schools in the country, that's an exaggeration, more than that had that, but very few schools in the country had access to actual computers. So the only way you got to code at all was to study computer science, right? It's a different world. So I would advise, in short, study some form of traditional engineering. Trad engineering, and then code on the side, or code while you're in school. So feel free to disagree. I'm just speaking from my own experience and from my life and what I've heard from friends. I think this is a better way to go at the current moment, with computer science being how it is in 2025. So if you disagree, leave a comment. All engagement is good engagement. I appreciate your time. Thank you so much for watching. Like I said in the beginning of the video, I'm the Unhinged Engineer. I make professional development content for engineers like myself. Some of it's technical, some of it's not technical at all. Some of it kind of borders on that, like today's video did. And yeah, if this kind of content or just this phase of life I'm in, being a young professional trying to figure out how to help navigate all this stuff, which I'm sure is as overwhelming for you as it is for me, then I would highly recommend you subscribe to this channel. This is a place for you. So thanks all for watching, and I will see you in the next video.